Hey guys, let me show you how you can perform decimal division very quickly. Okay, this is Fun Maths and we have been doing a lot of videos on division. We've looked at basic division, we've looked at long division of different types with different examples, and today we want to look at decimal division. I want to encourage you because this video is going to be a little bit long, and so therefore you try your best to look at the video, watch this video from start to finish, because if you miss any step, you may now see questions that involve decimal division somewhere else and you are unable to solve them. Okay, so what is decimal division? It is a type of division whose quotient is a decimal. And of course, you know, each time we talk about quotient, we are actually referring to the answer. Okay, we're looking at the answer. In this decimal division, we are going to be looking at 4 cases. Okay, case number 1 is where the whole number division with a remainder. 2, whole number division and a decimal number. A whole number and a decimal number. Okay. 3, decimal number and decimal number. The above 3 cases will usually involve the dividend, right, being higher than the divisors. Okay, but something is different with the case 4. In case 4, it's where the dividend is smaller than the divisor, and we'll find this mostly in fractions. Okay, so I'll just put fractions here by the side. Okay, mostly in fractions. All right, so these are the 4 cases of divisions we are going to be looking at. But first, let me also elaborate why we do decimal division. So let's go to our drawing board and see what that means. You know, in basic division, for example, when we'd have 18 dividing 4, okay, we'll say that we have 18, we have 4 here. How many times will 4 be in 18? That will be 4 times. And so we'll have 16 here, and we subtract, and this will be 2. In normal division, we'll say this is remainder 2, and we are correct. However, as we move along, we do not want to have remainder. We want to have that remainder further divided. This is what I mean. Okay? And so when we have something like this, we are simply saying that we have 4 groups, and that each group receives 4 of these. Okay, 4 of this. Okay, and this is group A, this is B, this is C, this is D. Okay, remember that the remainder is 2, and this 2 can be something like this. And so in decimal division, we are simply saying that these 2 can be further divided so that we can have half and have half and have half and have half. 4 halves, 1 to each group, 1 to each group. Okay, and so in real terms, what this means is that assuming we have 4 mangoes or 4 oranges, 18 oranges to be divided to 4 kids, okay, we are saying that each kid is going to receive 4.5 of those oranges, 4.5. So rather than have it this way, we will have 4.5, where 0.5 in decimal equals to half. Okay, it means half. And so how do we go about getting these 4.5? And that's what decimal division is about, all right? And now that will be the first case where we have a whole number division with a remainder, and that's the first case. So let me solve this question for you to see how it's been done. Look at this. We go back to our normal division. We have 18 here, we have 4 here. Of course, we have 4, and then we multiply this, we'll have 16. We subtract, we'll have 2. Recall that the steps is D, M, S, B. That is divide first, you multiply the next, you subtract, and then you bring down if there is anything to bring down. So now we don't want these 2 remainder. We want to further divide this. And to do this, we are going to put a point here on the 18. This allows us to put the point on top of there. And so we can have 0 here, which can be brought down so that here will be 20. Okay, so now we say 20 divided by 4. It will go how many times? 5 times. And so we can say 4 times 5, that would be 20. And now when we subtract this, we'll have 0 and the division is done. And so we'll have 4.5. And this is a case for number 1. Let's take another example so you can see. We can have 16. We can have 16 divided by 3. Let's look at 16 divided by 3. So we can have something like this. 16 divided by 3. How many 3 are in 16? We have 4, because 4 times 3 is 12. And so we can subtract this. We'll have 4. Okay. At this point, we don't want this remainder. Okay. We don't want, okay, so we can actually have 15. We can actually have 5 of this here. Sorry about that. So we can have 5 of this, 5, so that we can have 3 times this is 15. That's why we must not choose something bigger. You see, when we did that, we have 4 bigger than the divisor, which made it to be incorrect. And so we can have 1 here. This allows us to put a point here and put a point here. Okay, so we have 0 here that we can bring down, and this will be 10. How many 3 are in 10? That will be 3. And so we multiply, we'll get 9. We subtract this, and that will give us 1. Okay, we can do that again and have 0 here, which we can bring down here. And so we can have 10. 3 into 10 will go 3 times. And when we multiply, we can have 9. And when we subtract, we'll have 1 again. You see that this obviously looks like something that we continue forever. And so in maths, what we do is that we put a bar here on this number, indicating that 3 will continue to reoccur or repeat. Okay, and so our answer for this would be 5.33. Okay, that's correct. Let's look at case number 2. And in case number 2, we said that whole number and a decimal number. So we have a case where we have a whole number and a decimal number. Let's look at this question. 494.16 divided by 3. Okay, so this is how we go about this. This is 3 here, and so this is 494.16. First question, how many 3 are in 4? That will be 1, indicated there. You multiply, it gives you 3. You subtract this, this will give you 1. You bring down your 9. Okay, so we can have, okay, so when you bring down your 9, that will become 19. How many 3 are in 19? That will be 6. 3 times 6, that's 18. You subtract this. This gives you 1. You bring down your 4. This becomes 14. How many 3 are in 4? That will be 4. 14. So 3 times 4 is 12. You subtract this, and this will give you 2. Okay, you put back your point where it is. You can bring down your 1 here. So this becomes 21. How many of these are in 21? That will be 7 times this. That will be 21. You subtract this. You subtract this. This will give you 0. So you can be able to bring down your 6 here, and this is 6. Okay, how many 3 are in 6? That will be 2. You multiply, that will be 6. You subtract, this will be 0. And so your answer will be 164.72. 164.72. And this will be correct. Okay, this is case number 2. All right, case number 2. Let's look at another example so you can see how this is done. Excuse me. Let's take another example where we have 800.50 divided by 50. And so we can have this 800.50, and we can have 50. Okay, how many 50 are in 80? That will be 1. You multiply, you have 50. You can subtract, this will give you 30. Okay, so now you can bring down the 0. This is 300. How many 50 are in 300? That's 6. You multiply, that will give you 300. You subtract, that will give you 0. Now you can bring down your 5. Okay, and put your point where it is. How many of these is here? It cannot go into 50. Okay, 5 divided by 50 cannot go. So you simply put 0 here. It allows you to have a 0 here. Okay, and so of course it means you could bring down this also. So 50 divided by 50, that would be 1. You multiply this, that would be 50. This will be 0. Okay, all right, let's look at case number 3. Case number 3. Case number 3 is where we have a decimal number and a decimal number. This 50.4 divided by 2.2. You see that the dividend is a decimal number and the divisor is a decimal number. So first thing we want to do is to move away this point here. And to do that, we have to multiply both sides by 10. And so for 50.4 times 10, we would have 504. And for 2.2 times 10, we will have 22. And so our new division will be done with this and this. And here is what I mean. So we can now have 504 divided by 22. How many 22 are in 50? That would be 2. So you multiply this, that will give you 44. You subtract, this will give you 6. You can bring down your 4. This will be 64. How many of 22s are in 64? That's another 2. Okay, and so that when you multiply, you can still have 44. You subtract, this will give you 4 minus this is 0, and this is 20. Okay, 20 is less than 22, and so to be able to go on with this, you will have to have a point here, and this gives you a point here, so that you can have 0 here that you bring down here. And when you have that, that becomes 200. All right. How many of these 200? How many of 22 are in 200? That's 9. You multiply this, it will give you 198. You subtract, this will give you 2. Okay. This will give you 2. And because it gives you 2, 2 is less than 22. And so you can have another 0 here, which you can bring down. And this is 20. 20 is also still less than this. So it allows you to have this 0 here, so that you can have another 0 here. You can bring down. This becomes 200. And so how many 22 are in 200? That's another 9. Okay, when you multiply this, that will be 198. And when you subtract, you have 2. So it looks as though this 909 will continue in that order. The next one will be in that order of, 909, 909. And so we can simply have a dash here, indicating that this sequence of number continues forever, or as long as possible. Okay, so let's have another example for case 3. Another example for case 3 would be 50.4 divided by 50.4, yes, divided by 21, or 2.1. Okay, 2.1. I want you to look at another part where these numbers do not continue, and that's why we have a similar kind of question here. And so look at this. Of course, we're going to move away these points here by multiplying this side by 10 to have 504, multiplying this side by 10 to have 21. Okay, and when we do that, we'll now have 504 and 21 instead of the point. We've taken off the point. How many 21s are in 50? That will be 2. You multiply this, will give you 42. You subtract that, it will give you 8. You can bring down your 4, so you have 48. And then you can ask how many 21 are in 84, and that will be 4. When you multiply 21 by 4, it gives you 84. You subtract this, this will give you 0. And this becomes your answer. So we have looked at 3 cases, but if you stop watching this video now, you may also find another kind of division where we have the fourth kind of case, that is where the dividend is smaller than the divisor. And let me show you a question. And it usually occurs in fractions, especially when you are changing fractions to decimal. In something like this, you have 1 divided by 2. You can see in this place that the dividend is smaller to the divisor. Okay, so how do you treat questions like this? Here's how you do it. Okay, you have 1 here, you have 2 here. So you know that you cannot have this kind of thing happening. So how do you go about this? Okay, you know that when you have 1.0, it doesn't change that it is 1. You have 1.00, it doesn't change that it is T1. You have 1.000000 to infinity, it still does not change that it is 1. Okay, so that's the kind of idea we are going to be using here. So now that we have 1 here, we can have a point here, and if we have point here, we can have point here. Okay, and have a 0 here. So I want you to look at this 1.0 as 10 and not 1.0. Okay, so that you can now say 2 into 10, that will be 5. Okay, All right, when you multiply this gives you 10. When you subtract this gives you 0. And so you can have your 0 here. This means that 1 divided by 2 is 0.5. Okay, it's 0.5. It's as easy as that. Let's take another question on this. Look at this question. 3 divided by 6. Okay, you can have 3 here and have 6 here. The same way you do. You have your point here, you have 0, you have that point here. Okay, look at this as 30. How many 6 are in 30? That would be 5. You multiply this gives you 30. You subtract this gives you 0. And so this is 0.5. Alright, let's take another question, possibly 2, so that this will really go in. Look at 3 divided by 4. Alright, you can have 3 here and 4, so that you can have 0 here and have a point here. Okay, look at this question. 4 into 30, how many times will 4 go into 30? That would be 7. You multiply 4 by 7, that would be 28. You can subtract these to give you 2. And so you can have another 0 here that you bring down because we don't want any remainder. This makes it 20. 4 into 20 will be 5 times. You multiply that would be 20. You subtract this will be 0. So you can have your 0 here. That means 3 divided by 4 is 0.75. Okay, let's take one more example. One more example would be 1 divided by 3. And so you can have 1 here and have 3 here. And so you can have a point here and a point 0 here. So how many 3 are in 10? That will be 3. Okay, you multiply that will be 9. You subtract, this will be 1. How many 3? Okay, you can have 0 here and bring down. How many 3 are in 10? That will be 3. You multiply that will be 9. You can subtract, this will give you 1. It looks like this will go on and on. You can bring down this will be 0. How many 3 are in 10? 3. You multiply, that will be 9. You subtract, this will be 1. So you can see that this can continue almost forever. So we will just put a dash on the 3 to state that 1 over 3 is equal to 0.33 and a dash. Okay, indicating that 3 continues repeatedly. Okay, if you have a question, please, I would like you to leave it in the comment section. And you haven't followed this video or this channel, please do so. It helps the algorithm and it encourages us to bring good videos as this. Thank you so much for following this video to the end. Put down your questions there in the comment section. Bye for now.